Impulsive force. Impulsive force. It is a very large force which acts for a small duration of time, which is a varying force. So, a large varying force that acts for small duration of time is called impulsive force. We notice such a force during collisions. During collisions, a large force acts for small duration of time. Moreover, that force is not constant, it is a varying force. So, impulsive forces are applied during collisions. So, F is very large, it is a varying force, it acts for a small duration of time. Such a force is known as impulsive force. Impulse. Impulse. It is defined as the product of force and time for which the force acts. It is defined as the product of force and time for which the force acts. We know that F is equal to dP by dt, delta P by delta T. F is equal to delta P by delta T, where delta P is the change in momentum and delta T is the time in which the change takes place. If we consider a body of mass m moving initially with a velocity u, and if its velocity changes to v after in a time delta t, then F is equal to mv minus mu by delta t. F is equal to mv minus mu by delta t, where mu is initial momentum and mv is final momentum. From this relation, we will get F into delta t is equal to mv minus mu. From this relation, we get F into delta t is equal to mv minus mu. But by definition, F into delta t is the impulse. It is represented by J. Hence, J is equal to mv minus mu. To understand this impulse, we take a graph. We plot a graph between force and time. Force will be plotted on y-axis and time on x-axis. Then we show the varying force by a curve as shown in the figure. The area between the time intervals t1 and t2 between the graph and the x-axis, that represents the area represents the impulse G. Impulse delta t or J is equal to delta t change in momentum. It can be written as integral t1 to t2 ft dt. Here ft represents the force, the varying force with time. Dt represents the time interval, small time interval. Then this is in calculus if there is a varying function and if dt is the time interval with which the force is varying, then ft dt, if it is integrated between the time intervals t1 and t2, then we will get the total change in delta p. Like this we represent in mathematical form. This is measured with Newton's second. Impulse is measured with Newton's second. It is also kg meter per second. It is also equal to kg meter per second. Application of the impulsive force. Application of the impulsive force. When impulsive forces are present, if we can increase the impact of these collision forces, if we can increase the duration of the collision forces, then the magnitude of the impulsive force decreases. By increasing the time of collision, the impulsive forces can be decreased. This is noticed. A cricketer, while holding the ball which is coming with high speed, he will drag his hands while holding the ball. While holding a ball which is coming with high speed, the cricketer draws his hands backwards while catching it. In this process, he increases the impact of the ball with hands. Hence, the force that is needed to hold the ball will be less. We use springs in vehicles. Compression springs are shock absorbers. They are known as shock absorbers. They are nothing but springs. When we use these springs, the impact of impulsive force will be less. While going on a vehicle, if there are no compressive springs or shock absorbers, then we receive a greater blow with the seat. When the vehicle falls in a pit, then we will get a greater blow. It will be uncomfortable. When we use compressive springs. Then when the wheels fall in the pit, the seat falls slowly by compressing the springs. Hence, the time of impact will be increased. Hence, we receive less impulsive force. Impact time is more on sandy soil and less in a hard floor. When a person jumps onto a hard floor, time of impact is very less. The time of impact is very less. Hence, he receives greater injury because the impulsive forces are very large. The same person, when he jumps onto a sandy soil, his legs go into the sand. Thereby, duration of impact will be increased. The duration of impact will be increased, hence the impulsive force will be reduced. So, he receives less impulsive force. If a bullet is fired onto a glass pane, glass window, it makes a clean hole. Here, the bullet travels with high speed and the impact time is very less. So, the impulsive force will be very large. This force is greater than the molecular force between the molecules. Hence, the molecules which are struck with the ball will be removed, with the bullet will be removed. Hence, a clean hole will be made. If a stone is thrown over the same glass window, then the window breaks. The speed of the stone is less. Hence, the time of impact will be more. The time of impact will be more. And the impulsive forces are comparable to the molecular forces of attraction. Hence, the glass window breaks wherever the molecular forces of attraction are weak. Hence, we notice cracks in the glass window when a stone is thrown on it.